Good evening, students. Today we will do the chemical properties of phenols. Acha. In chemical properties of phenol, you will see the reactions are similar to those given by alcohols. Most of the reactions you will find it out similar to those given by alcohols, phenols. So that is the reactions of phenols due to OH group. We can say that. So first reaction you can see reaction with sodium metal. When phenol reacts with sodium, what it gives? Sodium phenoxide and hydrogen gas is released. What does this prove? This particular one. It proves that phenol is acidic in nature. Alright, it proves that phenol is acidic in nature. This reaction you have seen it in alcohol also, this particular one. Alright, similarly, when phenol reacts with acetyl chloride, CH3COCl, in the next reaction you can see, in presence of a basic catalyst, that is your pyridine, what do you get it? You get it phenyl acetate, benzene ring, OCOCH3. Now see children, you have to write this reaction. Many children, they make the mistake, they write COOCH3. Listen carefully. Benzene ring OCOCH3 and benzene ring COOCH3, both are different. Again I repeat, benzene ring OCOCH3, their oxygen is attached to the phenyl group. And when I say benzene ring COOCH3, their oxygen is attached to methyl group. There is a difference between that. So hence, practice this equation, write the reaction. You can see in the screen that what I have done. I have, that is, put the negative and positive charge. Like in phenol, oxygen I put the negative charge and hydrogen positive charge. And in acetyl chloride, CH3COCl, you can see over the carbon I put the positive charge, over the chlorine I put the negative charge. So H positive reacts with Cl negative to form HCl, and the remaining product is nothing but benzene ring OCOCH3. Write down in this way in your notebook, that is phenyl acetate, you will be getting it. Got it? Phenyl acetate. So in this way, these are the products you will be getting it here. Like the next one also same thing, you will be getting like phenol reacts with acetic anhydride. Acetic anhydride. Now acetic anhydride, there I have taken an acidic medium, that is sulfuric acid concentrated. What I get it? Same thing I get it, phenyl acetate and acetic acid. There also you can see I have marked the equation. Can you see it? I have made it in the box, the red pen, with a red pen I have made a box there. That is H plus of phenol reacts with CH3COO minus, you can see CH3COO minus to form what? CH3COH. Got it? So, and hence you get it CH3COH and same thing phenyl acetate. Okay. Next is when phenol reacts with benzoyl chloride. The previous one was acetic anhydride or ethanoic anhydride. The previous reaction, the reactant was. The product is, I hope you got it, phenyl acetate and acetic acid. In the third reaction, you can see phenol when reacts with benzoyl chloride, benzene ring COCl in presence of NaOH, that is a basic medium. Got it? So what you find is here is that you will be getting, that is nothing but phenyl benzoate. In place of CH3, here you will be getting C6H5. So it will be phenyl benzoate and HCl gas will be released. How HCl is released, you can see same thing. Here H plus ion is released. In all the cases you can see H is being released, hydrogen gas is released. In all the reactions, can you see it there on the screen? So it proves that phenol is acidic in nature, all these reactions. Same thing, when phenol reacts with NaOH, what do you get it? You get sodium phenoxide. Sodium phenoxide reacts with an alkyl iodide, CH3I or C2H5I or CH3Cl or C2H5Cl, correspondingly you will be getting anisole or phenitol. Means if it reacts with sodium phenoxide reacts with CH3I, you get benzene ring OCH3 plus NaI, that is your anisole. Okay, phenol plus NaOH will give you, what is that? Sodium phenoxide, and water is released. You can see I have written minus water there. Now when it reacts with CH3I, now instead of CH3I you can take CH3Cl or CH3Br. What it? You can take it, any alkyl halide. What you will be getting? You are getting anisole, benzene ring OCH3 plus NaI. Now what I said here, suppose instead of CH3I, if I take C2H5I, isn't it? Any alkyl halide. So what will I get? I will get benzene ring OC2H5 plus NaI. So what is benzene ring OC2H5? That is your phenitol. We can say phenitol. Got it? In this way you will be getting it. Or phenoxybenzene, we can say that. Like this one is methoxybenzene, the IUPAC name is. In this way you will be getting the different types of ether. This is what? This is an ether. Similarly, when phenol reacts with ammonia in presence of anhydrous ZnCl2 at 573 Kelvin, when you will be heating it, what you will be getting? You will be getting amines, benzene ring NH2, that is your aniline plus water. Got it? Now this reaction takes place with the OH group of the phenol. mind it there, OH group I am taking it there. Alright. Now this reaction does not prove that phenol is acidic in nature, this particular one, when it reacts with, that is your ammonia. Clear? So now we are getting aniline plus water is being released, we are getting. Got it? In other way you can say that here hydrogen is not released but here water is released here. So of course you can say phenol is acidic, ammonia is basic. Acid plus base reacts to form salt, that is aniline plus water. And that you can say that even NH2, what you find is that, of course you will say that it is benzene ring NH2. Is it a salt? No, it is not a salt, of course, benzene ring NH2. But what I said, if you compare with neutralization, then you can say this particular thing. Clear? If you compare with, you can say that phenol is acidic, ammonia is basic, so it reacts with anhydride ZnCl2, which acts as a dehydrating agent. Anhydride ZnCl2 on heating, it gives you water, and what is that remaining? Remaining is salt. It might be benzene ring NH2. Benzene ring NH2 is not a salt. It is a derivative of benzene, we can say that. Clear? Rather you can see aniline is being basic in nature, we can say that. How we can say? When you are reading the derivatives of what you can say nitrogen derivatives of benzene, at that time you will see it gives OH minus ions, which proves that it is basic in nature. Okay, clear? So now to understand, you can understand in any manner. To understand it, to remember it. Got it? There are different ways to remember it, that I just said you, one of the way. Clear? Now when phenol reacts with PCl5, it gives chlorobenzene plus POCl3 plus HCl. You can see that. Clear? You know that PCl5, I have said you always that first is your POCl3 and HCl. I gave you, if you remember it in that is alcohol, I gave you the reaction mechanism, that how it is being done. How it is being done. PCl5 you break it up. Alright, then you will be knowing it. You will be getting POCl3 and you will be getting HCl as a compulsory product, and the remaining is your chlorobenzene. Okay, fine. But here one thing more I want to add it here. Here chlorobenzene, which is being formed here, as you can see, it is a minor product. The yield of chlorobenzene is very poor. Alright, the main product is that here you will be getting triphenyl phosphate. The main product is. Now where from will I get triphenyl phosphate? Actually what it happens is that phenol further reacts with POCl3. If you want, you may write this reaction. Phenol will react with POCl3, will give you C6H5 whole thrice PO4. That is your triphenyl phosphate, which is a major product, plus HCl. If you balance it, then POCl3 na, so 3 chlorine is there, so 3 HCl will be formed, and 3 HCl means 3 phenol you will be taking it. So the reaction will be 3 phenol, 3 molecules of phenol plus POCl3 will give you C6H5 whole thrice PO4, that is triphenyl phosphate, plus 3 molecules of HCl. This is triphenyl phosphate which is being formed, that is a major product. Chlorobenzene is not a major product, it is a minor product. I hope you understood this particular thing. Got it? Now in this way, next is there are also what you can say is that some reactions which is different from those of alcohols, because I was talking to you the reaction which is given by alcohols in the beginning. I said you, like what you have seen it is that phenol is a weak acid. It behaves as a weak acid, not a strong acid like carbolic acid or mineral acid like HCl, HNO3, H2, so forth. It is a weak acid, but it turns blue litmus red, which is different from that of alcohol. Alcohol does not turn blue litmus red. Alcohol is neutral towards litmus. Alright, listen carefully. Alcohol does not turn blue litmus red. It is neutral towards litmus. But phenol turns blue litmus red. It proves that phenol is, that is weak acid. We can say that phenol is a weak acid. Clear? Now next is phenol reacts with alkali metals and their hydroxides to form salts. Means phenol when reacts with sodium, it gives sodium phenoxide and hydrogen gas is released. Alright, sodium phenoxide and hydrogen gas is released. Similarly, when phenol reacts with NaOH, it gives sodium phenoxide and water is released. We can say that. Clear? Water is released. Sodium, when phenol reacts with NaOH, it gives sodium phenoxide and water is released. Clear? In this way, what you get it is that when phenol reacts with NaOH, it gives sodium phenoxide and water. When phenol reacts with Na, you have already seen, it gives sodium phenoxide and hydrogen. Clear? It gives phenoxides. Now one thing, remember it, you got the difference between phenol and alcohol, that is it turns blue litmus red. Phenol reacts with alkali metals and hydroxides, and just now I said you. But phenols are unable to decompose carbonates and bicarbonates of alkali metals. Means if you take sodium bicarbonate or sodium carbonate, Na2CO3 or NaHCO3, phenol is unable to decompose. This indicates that phenol is a weaker acid than carboxylic acids. Carboxylic acid can decompose, means if you take Na2CO3 plus CH3COH, Na2CO3 plus CH3COH, you will be getting CH3CONa plus H2O plus CO2. But if you take phenol plus Na2CO3, no reaction will be there. Phenol plus what you can say NaHCO3, no reaction will be there. So this reaction differentiates phenol from carboxylic acid. Carboxylic acid reacts with sodium or potassium carbonate or bicarbonate to give the respective products, but phenol does not. We can say that. Clear? Understood the difference between phenol and alcohol, phenol and carboxylic acid. Alright, understood the difference. Now the acidic character, let me add one more sentence to it. The acidic character of phenol is mainly due to the presence of the polar OH group. Got it? And the resonance stabilization of phenoxide ion. Now you might say here, okay, sir, we have already read in alcohol also the polar OH group is there. Correct. But what you read it in alcohol? Recapitulate it. In alcohol you studied alcohol when dissociates it give RO minus alkoxide ion and H plus ion, and alkoxide ion is not stable. It is not stable. The reaction is reversible for that reason. But what I said you here, again I tell the sentence. The acidic character of phenol is mainly due to the presence of polar OH group and the resonance stabilization of phenoxide ion. Here the phenoxide ion is stable due to resonance. There the alkoxide ion was not stable due to resonance. We can say that. It was not stable due to resonance. Hence, what we find is that phenol is more acidic than alcohol. I hope you understood. Thank you very much.